today's lesson, we're going to talk about the properties of logarithms. So the first thing that we're going to talk about is what's called change of base. So we know a logarithm has a base, and in this case, our base is a. So what if we want to change it? What if we want it to be log base 10 or the natural log? So to change this, you can change it to any base, but this is their examples of showing log base 10 and the natural log, which is log base e. So on the top, you take the log of the argument. So here's our argument, goes on the top, and I always think of it as the base goes on the bottom. So you're going to take the log of b divided by the log of a, and you can do that again with any base to change it. So if you're looking at this next one, we could rewrite this as the log of 91 over the log of 23. Or you can write the ln of 91 over the ln of 23. But again, you can use any base. So here are our main properties of logarithmic functions. So some of these we talked about in the last section. So the last section we talked about these first three. We said when you have log base b of 1, that's always going to be 0. Because if you raise anything to the 0 power, we're going to get 1. The next one, log base b of b is 1, because if you raise b to the first, you're always going to get b. Same thing with the next one, log base b of b to the x is going to be equivalent to x. Now, the third one kind of goes with the fourth one. When you have the base is the same as the base of the logarithm, and that logarithm is in the exponent, they kind of cancel each other out. So then your answer is just x. Now, the ones on the right side are a little bit different. So if you see multiplication with logs, so you have log base b of m times n, then you can separate it. You can expand it into two pieces. So you'd say log base b of m plus log base b of n. Now with division, when you say log base b of m divided by n, you can change it to subtraction. So the top piece is your positive piece. So log base b of m minus log base b of n. So whenever it's in the bottom, it's going to be negative. When it's in the top, it's going to be positive. Our next property says, okay, if you have an exponent here, you can move it to the front, and that is equivalent. The last one we kind of talked about in the last part as well in the previous section. And if you take the log base b of m equals the log base b of n, then that means the two arguments have to be equivalent. So it says m equals n. Okay, these are going to be used more in the next section when we have to solve logarithmic equations. So this first one says rewrite the ln of 45 in terms of the ln of 3 and the ln of 5. So what we have to do is we have to break this 45 apart. So we can write it as the ln, well, really that is 3 squared, which is 9, times 5. So if we want to break that apart, we could say the ln of 3 squared, multiplication, we know changes to addition, so plus the ln of 5. Now, we do have one other property. We have this exponent on the 3, so then that would be equivalent to 3 ln, oops, sorry, not 3, how about 2 ln of 3 plus the ln of 5? And that's what that question is asking you to do. Now, on the next one, rewrite this log as sum and differences of multiple logarithms. So again, we're doing the same thing. If it is on the top, we're going to say it's positive. On the bottom, we're going to say negative, because with the division, remember, we subtract. So we would say the log of x squared, that's going to be our positive piece, minus the log of 5. Now a is also on the bottom, so I'm going to say minus the log of a. Now, some of you might say, well, but that's 5 times a, which yes, it is. You could also write that as log of x squared minus the log of 5 plus the log of a. But notice what you're going to have to do. You're going to have to distribute that negative anyways. So here we are. Now, we still have this squared on the x, so we do need to move it out front. So we'd say 2 log x minus the log of 5 minus the log of a. Okay. Now, The next one is going the other direction. So we are condensing. We're going down to a single logarithm. Again, if it's positive, it's on the top. If it's negative, on the bottom. Single logarithm means you are only allowed to write the log one time. So make sure you do that. And then we're going to put a fraction bar in here. So again, like I said, if it's got a positive sign in front, it goes on the top. So we know x goes on the top. The y has to go on the bottom. Now you got to be careful with this last piece, because really what I should have done first is rewrite it as ln of z squared. And now we see that that has a minus in the front, so that z squared needs to go in the bottom. Here are some more examples. So again, if we're doing the ln of 20 and we want it in terms of ln of 2 and ln of 5, it's ln of 2 squared times 5, which is going to give me 2 ln of 2. Again, move that exponent out front, and it has to be positive, plus the ln of 5. So we've expanded that. Sum and differences, again, we're doing the same thing. It looks a little more complicated. We'd say the log of x minus 1 squared minus the log of z to the 3 halves. Now, again, we have these exponents. We have to move them out front. So I'd have 2 log x minus 1 minus 3 halves log of z. Again, single logarithm. And so we are going to write log one time. And look, we have all positive things. So there's no negative. Let's see what happens. Well, we would have c times a times b times I times n. And so we have a log cabin. And yes, that's cheesy, but something to help you remember. The last one, again, we have to move those exponents up. So we'd say the log of y to the 1/2 minus the log of z to the 1/3 plus log of x squared. Again, if it's positive, it's on the top, and negatives on the bottom. Single logarithm, you're only allowed to write that log one time. So the first log is positive. Now, you can think of the 1/2 power as the square root. You don't have to change it, but you can. So I'm going to write the y to the 1/2. You could write square root of y there and be okay. The next one is negative. So we have z to the 1/3. I'm going to put that on the bottom. Again, that would be to the 1/3 power or the cube root, either way. And then our last piece, our x squared, is positive. So we're going to put that on the top. So hopefully that gives you a good start on this lesson. If you have any questions, make sure that you send me an email. Have a great day.